Imagine walking onto a factory floor, and instead of just the usual robotic arms, you see machines that look, well, human-like,
Yep.
walking around, opening doors, using tools, maybe even interacting with people.
Yeah, it's always felt a bit sci-fi, hasn't it? Like something out of a movie.
Exactly. But it feels like this week something really shifted. Welcome to Tomorrow Unveiled. Today, we're diving into the rise of the machines this week in robotics. We're focusing on this incredible acceleration we're seeing, especially in humanoid robots becoming, real-world possibilities.
Hmm.
Our mission today is to unpack what our dedicated research team has found, looking at the findings corroborated across all the information they've compiled. It suggests we're moving past lab experiments towards actual viable industrial platforms.
Definitely.
And this isn't theory, right? This is stuff happening now, particularly just in the last 7 days or so.
It really feels like an inflection point. That's
Yeah.
what the data we've looked at points towards. It's this confluence, um, a whole bunch of major announcements and tech advancements all hitting at once that have pushed humanoid robots right to the forefront.
So they were prototypes, but now,
Now they're seriously in the discussion for commercial use. And the humanoid shape itself, that's key. It's just so versatile for working in places built for us, stairs, doors, tools.
right, environments designed for humans.
Exactly. And there's a potential to directly tackle some of those big labor shortages we see across industries. That really sets them apart from, say, a specialized robot arm.
Okay, so let's unpack this. What exactly happened this week that got everyone talking about humanoids? You mentioned groundbreaking unveilings.
Yeah, absolutely. So first up, there's Hexagon's AEON.
AEON, okay.
And this isn't just like a general bot. It's specifically designed as an industrial humanoid for high-precision tasks. It really leverages Hexagon's background in measurement and sensor technology.
So playing to their strength.
Precisely. Our analysis shows it stands about 165 centimeters tall, so roughly human height. It's got 34 degrees of freedom.
Which means what exactly? For movement.
Yeah, it's a measure of its articulation, how many ways it can move its joints. 34 is quite a lot, allowing for really fluid, precise movements,
Yeah.
which is crucial when it's handling its 8-kilogram payload for complex jobs.
Okay, 8 kilos. And it keeps running.
It's got a quick swap battery system, so yeah, designed for continuous operation. But what's really interesting, and our research highlighted this, is the simulation-first approach they took,
Simulation first.
using Nvidia's Isaac platform. They basically built and tested thousands of versions virtually before making the physical robot. And apparently this cut development time from potentially months down to weeks.
Wow, so iterating super fast in the virtual world.
Exactly. It's a fundamental shift. Cheaper, faster, lets you explore way more possibilities. And they're not just talking about it. They've already got pilot programs lined up with big names like Pilatus in aerospace and Schaeffler in automotive.
For things like
High-value stuff, part inspection, reality capture for making those digital twins of factories. Really playing to that precision angle.
that precision focus with AEON plus the rapid development. That's impressive. But I guess not everyone's taking that exact same path, are they? Who else is making waves?
No, definitely different strategies emerging. NURE Robotics, for instance, just unveiled the third generation of their bot, the Forerunner.
Forerunner. Okay, what's their angle?
Their big thing seems to be safe and intuitive human collaboration. This one's a bit bigger, 180 centimeter, 80 kilograms, and can handle a 15-kilogram payload.
So stronger, but focused on working with people.
Right. It's got this advanced sensory suite. They mentioned a patented omnisensor and even something called artificial skin, which can detect touch before contact actually
Or
happens.
pre-contact. Wow, okay, for safety.
Exactly. Super important if it's working right next to a human. It also has a smart dual battery system for 247 operation. And interestingly, conversational AI, so you can interact with it using natural language.
Talking to the robot.
Yeah. But maybe the most innovative piece, based on our findings, is how they plan to build them. They call it the near-eye hive,
NURE hive.
using robots to build robots. It's not just a clever production line. It feels like a direct attempt to smash those cost barriers that have always held back wider adoption.
Robots building robots to make robots cheaper.
Essentially, yeah. It promises scalability and affordability on a whole new level. Could really democratize access to this kind of tech, and maybe even reshape the manufacturing supply chain itself.
So we've got precision, we've got collaboration, but you mentioned one is already actually working, not just a demo, but on the job.
That's the Kepler Forerunner K2. They nicknamed it Bumblebee.
Bumblebee, okay. Where's it working?
There was a real-world demonstration, quite extensive, at a SAIC GM automotive plant over in Shanghai. Our team reviewed the footage. It was doing complex stuff. Quality checks, navigating the factory floor, handling fairly heavy components, loading parts into machines.
So proper factory work, what are its specs like?
It's about 178 centimeters tall, 85 kilograms, and get this, 52 degrees of freedom.
52. That's a lot more than the AEN.
It is. Gives it extraordinary dexterity. And the payload is 15 kilograms per hand.
Per hand. So 30 kilogram total if using both.
Potentially, yeah. Imagine carrying like 2 heavy bowling balls, one in each hand. That gives you an idea of the strengths for factory tasks. It's got a reinforced structure, tactile manipulators with flexible sensors on the fingertips.
And battery life. Can it do a full shift?
Yep. Integrated battery lasts a reported 8 hours, and it uses a cloud-based AI system for learning.
Cloud-based AI, how does that work?
It allows for rapid learning and adaptation. They mention imitation and reinforcement learning techniques so it can learn new tasks relatively quickly. But here's the kicker.
Go on.
The stated base price, around $30,000.
$30,000 for a humanoid robot doing factory work.
That's the number they've put out there.
Yeah.
It's potentially massively disruptive, positioning it as a genuinely cost-effective workforce multiplier.
Wow, okay, that $30 K figure for Kepler's K2 is, yeah, aggressive is the word. Does that signal a price war starting, or maybe just that the potential market is way bigger than we thought?
It could be a bit of both. Really, it definitely puts pressure on others. And speaking of big moves, it's not just these newer players, right? The established giants are getting serious too.
Let who?
Well, the data we gathered also flagged a really significant partnership. Foxconn and Nvidia.
Foxconn, the manufacturing giant, and Nvidia, the AI chip leader.
The very same. They have plans to deploy humanoid robots in a new Foxconn factory in Houston, Texas.
Yeah.
And soon, target is Q1 2026.
Deploying humanoids to do what?
To build NVIDIA's own AI servers. They're training the robots for tasks like picking and placing components, inserting cables, general assembly work.
So robots building the hardware that powers AI.
Exactly. And this isn't just a small pilot. It signals a real commitment to integrating these humanoids into large-scale manufacturing.
Yeah.
It's a major milestone, really rethinking the whole factory setup and pushing automation into areas that were too complex for traditional robots before.
Okay, so we've got these incredible machines, AEON, 4NE1, K2, and the Foxconn NVIDIA plan. But they aren't just, mechanical puppets. They've got sophisticated brains. How is AI actually making this all possible? Let's maybe shift focus to the software, the intelligence behind it all.
Yeah, that's absolutely crucial. And a big piece of the puzzle, according to our research, is NVIDIA's Isaac GR00T N1.5.
GR000T.
Like the character.
Spelled differently, GR000T.
But yeah, it's identified as really pivotal open foundation model for humanoid robot reasoning and skills.
Foundation model. Like GPT for language, but for robots.
Sort of, yeah. It's multimodal, takes in natural language commands like you telling it what to do, but also video from its cameras, and proprioceptive data.
Proprioceptive, that's its own sense of body position.
Exactly, where its limbs are, how they're moving. And crucially, this GR00T model can be adapted to control different kinds of robots, not just one specific type. The N1.5 update they announced showed a big jump in performance.
How so?
Especially in understanding and following language commands. The success rate apparently jumped up to 93.3%, which is impressive. And it's good at few-shot and zero-shot learning.
Meaning it learns fast with little data.
Right. It can grasp a new task from just a few examples, or sometimes even just from a verbal description, without needing massive amounts of specific training data for every single thing. That drastically speeds up how adaptable these robots can be.
That adaptability sounds key. But training AI usually needs tons of data, right? Where does that come from, especially for physical robots?
Well, that's been a huge bottleneck historically.
Yeah.
But the solution that's really unlocking this current wave is something called sim-to-real transfer.
Sim to real, so simulation again.
Exactly. Training the AI models in these super realistic virtual worlds, these simulations, you can gather data way faster, run thousands of training sessions in parallel, stuff you just can't do safely or quickly with physical robots in the real world.
But does learning in a perfect simulation actually work in the messy real world? That sounds like a leap.
That's the sim-to-real gap, and it is a challenge. But they use techniques like domain randomization. Basically, they make the simulation less perfect, adding random variations in lighting, textures, physics, object positions. This forces the AI to learn skills that are more robust and transferable to the unpredictability of the real world.
Okay, making the simulation messier helps it cope with reality.
That's the idea. And our research shows Hexagon and NEURA, Kepler, They're all heavily leveraging simulation, often using Nvidia's Isaac platform tools for this. Nvidia's even got tools like GR0T Mimic, which can create huge synthetic data sets from just a few human demos, and GR0T Dreams, which can generate new video scenarios from an image and a prompt. It's all about efficiently creating diverse training data.
So how does this embodied AI actually play out in the robots we discussed?
We're seeing it directly. Kepler's K2, with its cloud-based AI, uses imitation learning by watching, and reinforcement learning by trial and error to pick up new skills. Right. Hexagon's AEON has that data flywheel concept. The robot uses its sensors to capture reality, creating these detailed digital twins of its environment,
Which then become?
new simulation environments for more training. It's a virtuous cycle. NEURA, while using some Nvidia tools, also highlights their own proprietary ORA cognitive platform, focusing on independent decision-making and learning.
And AI isn't just for tasks, it's for safety too.
Absolutely critical.
Yeah.
The AI powers the perception systems that detect humans, predict their movements, and adjust the robot's behavior to avoid collisions and enable that smooth, safe collaboration we talked about with Forerunner 1. It's moving beyond just following commands to actually understanding intent and adapting on the fly.
This is fascinating stuff. You're listening to Tomorrow Unveiled, where we unravel the future one topic at a time. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and hey, turn on notifications so you never miss an update on the future.
And if you're listening on a podcast service, perhaps Apple Podcasts or Spotify.
Oh, right. If you are, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It honestly really helps us reach new listeners.
It does.
Okay, so we have these increasingly capable AI-powered humanoid robots entering the scene. But how do they actually fit into the bigger picture of industrial automation? Are they going to replace all the specialized robots we already have, or is it a different kind of game?
That's a really crucial question, and it brings up this classic dilemma. Specialist versus generalist.
Okay.
Humanoids are inherently generalists.
Right.
They're versatile, designed to potentially do many different tasks in varied environments, especially those built for humans.
Like moving around a factory floor or using different tools.
Exactly. Compare that to traditional industrial robots, maybe like Delta Electronics' new D-Bot series, which are highly specialized. You know, a robot designed only to move pallets, or only to do one specific assembly task extremely well in a fixed spot.
So one tool for every job versus a Swiss Army knife.
That's a good analogy, yeah. For businesses, it becomes a strategic choice. Do you invest in a fleet of potentially cheaper single-task robots? Or do you go for these more expensive but potentially much more flexible multitask humanoids?
And the humanoids have to prove their worth.
They absolutely have to prove that their flexibility and versatility genuinely outweigh the sheer efficiency you get from a specialized machine doing the one thing it was designed for. It's really a battle shaping up for the future of the factory floor, and the outcome will definitely reshape automation strategies.
Okay, connecting this all back, what does this actually mean for us, for people? Where are we likely to see these robots first, and what are the big implications, especially for jobs?
The research we've looked at consistently points to a few immediate beachhead markets. Think industrial manufacturing, warehousing, logistics.
Why those first?
Well, they often face significant labor shortages, and they have many tasks that are physically demanding or non-ergonomic for humans. So there's a clear need and a strong business case.
Makes sense. And longer term.
Longer term, you could see them in high-risk operations, think disaster response or nuclear decommissioning. Possibly healthcare, assisting nurses or doctors, maybe even retail, helping with stocking or customer service, and eventually, perhaps, domestic assistance in homes. But those later applications need much more sophisticated interaction skills and, frankly, a higher level of public trust.
Right. The home environment is way less structured than a factory. Are there still big hurdles to overcome?
Oh, definitely. Progress is fast, but challenges remain. Technically, perfecting that sim-to-real transfer is ongoing work. Making hands and manipulation as dexterous as humans is still incredibly hard, though these new models in AI are making strides.
And power, keeping them running.
Yep, power and endurance. You need large batteries or those hot swappable systems like AEON has. Then commercially, the unit cost is still a factor. Although it's dropping fast, that Kepler $30 K figure is a huge signal.
And can they even make enough of them?
Scalable production is key. Concepts like NURE Hive aim to address that. But building reliable supply chains for complex machines like this takes time, and overriding everything is safety and reliability. You need those advanced sensors, robust AI safety protocols, and rigorous testing in real-world pilots like Hexagon's doing.
Okay, so the technology is advancing rapidly, costs are coming down, but there are still hurdles. What about the impact on the workforce? That's the question everyone asks.
It is, and it's important to be realistic. Yes, there's potential for job displacement in roles that are primarily physical and repetitive. That seems unavoidable.
But
But the research also consistently emphasizes the creation of new roles. Think about it. You'll need people to manage fleets of these robots, people to train the AI, specialized technicians for maintenance and repair.
yeah.
It's less about pure replacement and more about a reallocation of human work towards more complex, creative, or supervisory tasks.
So a shift in the types of jobs available.
Exactly. And the economic forecasts are, frankly, staggering. Some predict a multi-trillion-dollar market for humanoid robots by 2035 or 2050. The pace of change itself is probably the most striking thing our research team flagged. Capabilities are improving monthly, not yearly now. We really seem to be on the steep part of the exponential curve.
A multi-trillion-dollar market, improving monthly. It really does feel like we're at a pivotal moment. Which raises the big question, I suppose. How do you personally see the rise of these machines shaping our tomorrow? We've seen this inflection point, these specific new models like AEON, 4NE1, K2, the huge role AI and simulation are playing, and these massive economic and workforce shifts starting to unfold.
It's a profound transformation, no doubt.
We'd love to hear what you think, too. Whether you're watching on YouTube or listening on your favorite podcast app, please leave a comment. Let us know your take on this week in robotics and the whole humanoid revolution. What stands out most to you?
Yeah, definitely curious to hear perspectives.
It seems increasingly likely that the future of work involves, well, humans and humanoid colleagues working alongside each other, augmenting what we can do, taking over tasks that are maybe dirty, dull, or dangerous for us. This rise of the machines isn't some far-off sci-fi trope anymore. It feels like it's here, now, and moving much faster than maybe many of us anticipated.
The pace is key.
The real question isn't if it's happening, but how we engage with it, how we adapt, and how we shape this future proactively. Join us next time on Tomorrow Unveiled as we continue to explore what's next.